So now, okay, as per our understanding, okay, so when I say cluster, cluster is nothing but a set of servers actually working like a single unit. Okay, so a set of laptops. Okay, if I interconnect okay, 10 laptops, okay, all these 10 laptops group is called as one cluster. Okay, so the same way, okay, so in real time, okay, you will not be having the laptops, you'll be having the servers actually. So server also, what is the difference between okay, a laptop and server? Normally, when I say laptop, okay, so I know there are people okay from civil background also. Maybe for them, okay, it's difficult to understand what is laptop and what is server. Okay, when I say normally laptop, okay, so how much RAM you will have normally in laptop? Much RAM? Mostly 16 GB. Okay, 32 GB. Arcus. Normally, this is the 8 GB, 16 GB or 8 GB, 16 GB or 32 GB. This is the RAM okay, normally you will have in laptop. Okay. But when it comes to server, okay, you will have okay 128 GB RAM or okay 256 GB RAM or okay 512 GB RAM or okay 1 TB RAM. Understood? Okay. So normally, so this is the capacity of server. Okay. So high end okay, I can say high end server is nothing but high end laptop. Okay. When it comes to cores, processor. So when it comes to processor, you may be having okay 4 or 8 okay 8 or 16 with CPUs. Okay, but here it is like okay, so 32 okay, or 24 or 32 or okay, okay 40 40 60 80 okay, these many cores. Okay, so hard disk also normally when it comes to laptop okay, you may have 100 GB or 1 TB or 2 TB hard disk. Yes or no? But when it comes to server, you will have 10 TB starting with 10 TB, okay, 20 TB, 100 TB. Okay, up to, you can have up to 200 TB. 200 TB in one machine base. Okay, this is a server. Okay, laptop means okay for our individual use. Okay, a small RAM, small core, small size of hard disk. But when it comes to server, okay, you will have okay, so very big RAM, very, okay, so many cores and okay, so much of hard disk also. Okay, so this is the difference between laptop and servers. Okay, so real time when people are installing Hadoop, okay, so they'll not install Hadoop on laptops, they'll install on Hadoop on servers. Okay, so when it's a cluster, okay, if I take 10 servers, so in Hadoop world, okay, each server can be called as okay node. Okay? Even of node. Even of node. When I say node, it is nothing but a server actually. So okay, so here okay, I have a cluster. Okay, I have a cluster with 10 servers or 10 nodes. Okay. If somebody says that okay, I have a cluster with 2000 nodes, what does it mean? I have a cluster with 2000 nodes. What does it mean?
2000 servers are there.
2000 servers are there in the cluster. Okay, 2000 servers are connected like a single unit actually. Okay, so that's the reason okay, we say it is a 2000 node cluster. Okay, so here okay, this is your cluster. Okay, normally when I say your cluster, so your cluster will have one okay master node. Okay, so but why I am saying one master node? Okay, master server. Okay, so why I am saying this one? Because okay, so this is the node okay, which is running with the master service. What is the master service in our Hadoop?
Name node, sir.
Name node.
Name node. Okay, and okay, so there are other servers which are running with the worker service. Okay, so what is the worker service okay we have in Hadoop? Okay, data node.
Data node.
Okay? So name node is a master service and data node is a worker service. Okay, so when I say normally Hadoop cluster, you will have okay minimum one name node and okay, and you can have up to 25,000 data nodes in this moment. Okay, but do you know okay, so when I say cluster, it is a set of servers or nodes, right? You know what is the world largest cluster? Okay, how many nodes it has? Hadoop supports, okay, 25,000 data nodes, up to 25,000 data nodes. Okay, but do you know world biggest cluster size? What is the world biggest cluster size? The world biggest cluster size is having around 6,000 nodes. Understood? Still, it has the capacity of 4 times. Yes or no? Still, it has the capacity of 4 times. Just 1 second. Okay. So clear, guys. Okay. So it means the world largest cluster in, itself is having only 6,000 nodes. Okay. But okay, a cluster can handle up to 25,000 nodes. Okay. What does it mean? What does it mean? Hmm?
25,000 servers.
So you can go up to 25,000 servers actually. Okay, you can go up to 25,000 servers. Just 1 second. Okay, so it means okay, you have the capacity. See, only 0. Only 25% of the Hadoop capacity is used. Okay, and build a world largest cluster. Okay, but still okay, it can handle okay 3 times more servers. Okay, up to 25,000 servers. Got it. Okay. So when I say any cluster, okay, it will have one name node, minimum one name node, and multiple data nodes. Okay. So how many data nodes are required is purely depends on how much data you have. Yes or no?
Yes, sir.
Okay. It is okay. Suppose okay, if your data is growing, you will be adding more and more data nodes. Clear? Okay. So now let us understand. Okay. Let us understand what are the major services in Hadoop storage layer. Okay. So the first one is name node. What is name node here? When I say name node, it is a master node in Hadoop cluster. Okay, master node in Hadoop cluster. It is responsible to store Hadoop distributed file system metadata. Okay, what name node is doing? Okay, is it loading actual data blocks or it is loading the centralized fact?
It's loading the information of the actual data, sir.
Exactly. So it is not loading any actual data. It is loading, okay, centralized metadata. Okay, so that's what it is saying. Okay, distributed file system metadata. It means like information about your file name, path, ownership, permissions, timestamp, size, replication factor, name of individual blocks, location of the file blocks. All this information will be stored by name node. Okay, and it is the first point of contact for all SDFS operations. Okay, what do you mean the first point of contact? Okay, see, if you say normally, okay, you have a SDFS, it means distributed file system. Okay, Hadoop distributed file system. Okay, so it is a storage. Okay, so when I say storage, okay, so what you will do, so you may write new file into that storage. Or okay, you may delete existing file from the storage. Or okay, you may rename. Or okay, you may move file from one directory to other directory. Okay, so these are the operations you will do. But okay, any operations you perform on HDFS on the storage, okay, the request will be given to first. Okay, the request will be given to name node first. Okay, without name node intervention, no operations will happen on this distributed storage. Are you clear?
Yes, sir. Clear.
Okay.
Yes,
So
sir.
next one is data node. Okay. So data node is like a worker node or a slave node in the Hadoop cluster. Okay. You can say worker node also in the Hadoop, worker node or slave node in the Hadoop cluster, and it is responsible to store actual data in the form of blocks. Okay. So now if you see Hadoop cluster here, guys, I will put a Hadoop cluster here. Okay. I'll put a Hadoop cluster. Okay. So this is server one inside this machine, inside the server one. So NN means name node, guys. NN means name node. Name node. Okay. So I have name node running in this machine. I have okay server two. So I have okay, it's a name node. So here okay data node DM. Okay. I have server three. I have server four. Okay. I have server five. Okay. I have server six also. Okay. Okay. Fine. Okay. Let's go with this. Okay. Okay. We will create one more server six. Okay. Now I will call this as a 6-node cluster. Will you agree with me? Is it a 6-node cluster or not? Okay. So now I'll put a
Yes,
box
sir.
here. Okay, I'll put a box here. So that okay, I will call this as a cluster. Okay. So this is my Hadoop cluster, guys. Now, okay. So now inside this one, what I will have? Okay. So what name node normally will we have? Name node will have centralized
Metadata. Yeah, fact.
file allocation table.
Yes.
Centralized file allocation table. Okay. So here, okay, so here data nodes will contain the data blocks. Okay. Now we need to understand, okay, so we need to understand what is data and what is metadata here. Okay. Let us take this scenario, guys. Let's say I have a file here, guys. I have a file. Okay. The file name is sample.txt. Sample.txt. Okay. The size of the file is 256 MB. Okay. The content here is that okay. Hello. Okay. How are you today? Okay. So welcome to Hadoop class. Okay. So this is the file content. Okay. So the size of the file is 256 MB. Okay. The content is hello. How are you? Okay. How are you today? Welcome to Hadoop class. This is the content. Okay. So when we write this data into Hadoop, when you write this sample.txt into Hadoop, so normally to write this one, let's say this is Venkata's file. Okay. So what Venkata will do? Venkata will execute a command. Okay. Execute a command. Okay. When Venkata execute a command in the background, what will happen? So this will invoke. What it will invoke? Writing algorithm. Okay. What writing algorithm will do now? Okay. Writing algorithm will go on here. Okay. Will contact name node. Why it is contacting name node? Name node is the first point of contact. Okay. So think that okay, inside centralized path. Okay. So what information you will have? Okay. So this is centralized path case. So this is a table here actually. Okay. You will have serial number, okay, file name, path, okay, permissions, timestamp, okay, permissions, timestamps,
Owner.
owner, permission, timestamps. Okay. So
Blocks.
block size, okay, block numbers. Okay. So that this is the information it has. This is the table which will maintain all this information. This is the table. Okay, will you agree with me? So
Yes.
initially that okay, this is the table which has nothing. Okay, initially you don't have anything inside this one. You don't have anything inside this one. Okay. So now what will happen? Okay. So Vector has this file. Just 1 second. Now. Okay. So now Venkata has a file sample.txt. So he will execute a command to copy this sample.txt into Hadoop cluster. This is the Hadoop cluster. Okay. This is the Hadoop cluster. Okay. So now what writing algorithm will do now? Okay. What writing algorithm will do? This is the writing algorithm. Okay. Okay. So now writing algorithm will directly contact name node and ask, hey name node. Okay. So Venkata has asked me to copy this file into your storage. Please let me know. Okay. Please give me your approval. Okay. Now what name node will do? What name node will do? Okay. Name node will check in the centralized fact. Okay. Name node will check in the centralized fact. Okay. What will check in the centralized fact?
Whether the file exists or not.
Whether the file
Yes.
is already existing or not. Okay. Is it existing, guys? Okay.
No.
Now, if you see here,
No.
the
No,
centralized
sir.
fact is completely empty. Okay. The file entry is not available. Okay. So now name node will, okay, approve writing algorithms request. Okay, writing algorithm. Okay, you can start writing your data. Okay. So what the writing algorithm will do? Writing algorithm will cut the data into pieces. Okay. So how many pieces okay, it will get?
2 pieces.
So it will get 2 pieces. Okay. So this one, okay, of size how much?
128 MB.
Okay. This two of size 128 MB. Okay. So now piece one is what do you mean of piece one here? Okay, maybe from here to here. Okay. Hello, how are you today is in piece one. And welcome to Hadoop class is in piece two. Yes or no? Yes or no, guys? This is the piece one, this is piece two. Okay. So now after cutting the data into pieces, now writing algorithm, what it will do? It will ask name node, hey name node. Okay, I've cut my data into pieces. Okay, these are the 2 pieces I got. Okay, can you give me
Block numbers.
block number and okay location of the data nodes? Okay, in which data node I need to write. Okay, so here, so data node, okay, here I will take it like data node 1, data node 2, data node 3, data node 4, data node. Okay, so these are the 5 data nodes okay, what we have actually. These are the 5 data nodes what we have. Okay, so now it will ask for which data node. Okay, so now what name node is telling? Okay, writing algorithm. You do one thing. Okay, you write the first piece with the name BLK001. Okay, and put in the nodes. Okay, so data node 1, data node 2, data node 3. Okay, and it is telling that okay, hey, writing algorithm, you write the second piece with the name BLK002. Okay, and write into DN3. Okay, DN4, okay, DN4. DN5, DN3. Is it fine?
Yes, sir.
So now, who confirmed this information?
Name node, sir.
Name node confirm this information. Okay. So now, what writing algorithm will do? Writing algorithm will contact data node 1 and ask, hey, data node 1. Okay. Hey, can you write my piece of data? Okay. Into your storage with the name BLK001. Okay. So now, we'll write. Okay, so now, data node 1 will write BLK001 here. What is the size of BLK001?
128.
This size is nothing but
128 MB.
128 MB. Okay, so what is the content of this one?
How are you today?
Huh? So how are you?
Hello, how are you today?
Karnataka. So the content of this one is hello, how are you today? Okay. So this is the content. Okay. In the same way, so the same block will be written in data node 2, data node 3 also. Right? Yes or no? The same block, the block 1 only will be written in data node 1, data node 2, and data node 3. Correct or not?
Yes.
Data node 3. Okay. In the same way. Now, okay. So first copy is done. The second copy. Okay. So the name of the second piece is BLK002 and it will be copied in DN4. Okay. So here, okay, you will have BLK002. What is the okay, again size of this BLK002? 128 MB only. What is the content inside this one?
Welcome to Hadoop class.
Welcome to Hadoop class. Will you agree with me?
Yes.
Okay. So and it is in DN3 also. Okay. So now you see. So your block 1 is copied 3 times, and your block 2 also copied 3 times. Yes or no?
Yes, sir.
Okay. So now once the work is done, once the data copying is done, okay, immediately, okay. So once it is written successfully, what writing algorithm will do? Okay, writing algorithm will inform name node saying that, okay, hey, name node, as per your instructions, I have written my data pieces in the data nodes, in the given data nodes. Okay, please update your metadata entry. Okay, so now what name node will do? Now name node will put it here. One file name, sample 1.txt. Okay, okay, so this is put sample, I guess it is related with sample 1.txt. Okay, sample 1.txt. Okay, so part. Okay, so here, okay, so slash project one owner. Okay, Venkata, permissions, create, write, and execute. Timestamps. Okay, so here, so block size 128 MB. Okay, and block numbers. Okay, so BLK 001, BLK 002. Okay, but BLK 0, where is BLK 001? DN1, DN2, DN3.
And 3.
Okay, and where is BLK 002? Okay, DN4,
Three, four,
DN5,
five.
DN3, DN4.
DN5.
Okay, clear? Clear, guys. So it updated the metadata entry. Updated the metadata entry here. Okay. So once again, now name node will confirm. Okay. Okay. Writing algorithm. Okay. I updated the metadata entry. Okay. So thank you so much. Okay. Now writing algorithm will be closed. Yes, sir.
Yes, sir.
You understood this concept? Okay. So
Sir,
now you should understand.
hello, sir.
Sir.
The file size is 256 MB, na? You written there in FAT 128 only.
Okay. Okay. Block size to 26
Okay.
26 MB.
Okay.
Okay. File size here.
Okay. Thank you.
File size is okay. So 26 MB. Is it clear now? Huh? Yes, sir.
Thank you. Thank you, sir.
Okay. Guys, okay. See, now, okay, you know what is actual data and what is metadata. Okay. So what is metadata? This is-
Information about the data in this one.
Okay.
Information about.
Okay, this is about, this is actual data in the form of pieces. Okay. Sir, okay. Actually, I thought, okay, see, we completed 3 classes. I thought at least one person will ask us, sir, whatever you are telling, what is the proof, sir? Nobody asked me. Hey, here, okay, so we have around 50 people, okay, and you all 50 people are new to Hadoop, right? Huh? What is the guarantee that whatever I'm teaching you is correct? Have you ever thought? Have you ever thought, okay, Venkat sir is teaching, cheating me, not teaching, cheating. Huh? Okay, so we will do one thing, guys. Okay, we will do one test actually. Okay. Okay. So let's go to the initial class. Okay, I told that, okay, whatever data you store into storage, okay, it will be divided into 4 KB blocks and stored into hard disk. Correct?
Yes,
This is
sir.
what I
Yes,
told,
sir.
right? Okay. So we will see something. Okay, we will see. Okay, something. Okay, you can take anything, guys. Okay, so here I have sample.txt, guys. This is sample.txt. Okay. Okay, I'm just clicking on properties. Okay, so here, okay, it is not updated. Okay, so what I will do, so I'll take some other file. Okay, so fine. Okay, so here, you take this file. Okay, high performance tuning. This is the file. Okay, now if I right click on this one, okay, if I click on properties, okay, when you click on, when you right click on a file and see the click on properties, whatever you are seeing here, okay, is this the information about your file or not? High performance tuning. Okay, this is a text file. Okay, this is the path. Okay, this is the size. So what is the difference between size and disk, guys? What is the difference between size and disk?
Size on disk is block size.
Size allocated on disk.
Size is the actual size.
Size is okay. See, Okay, we discussed like even if you put like a 1 KB file here, okay. So here, okay, so we discussed this, right? Okay. Somebody asked me also, sir, okay, what in case if I put 1 KB file? What will happen if I put 1 KB file? So here, okay. So here, okay, what okay, this guy has done. So he has okay, written a file which is less than 4 KB. So it occupied only single block. Okay, a single block. Okay. But here, if you see, the actual file size is 1.19 KB, but okay, but it occupied 4 KB on the disk actually. What does it mean? It has utilized full block. Yes or no?
Yes, sir.
Yes, sir.
Okay, it means okay, the remaining 2.88 KB is waste only. Got it?
Yeah.
Okay. In the same like we'll see some other file. Okay. So I have another file which is 14 KB file. Okay, we'll see. Right click on this one, show more options. Okay, properties. Okay. Now you see. Okay. So the size of the file is 13K.4, but size on disk is 16. Why like that? So now tell me if it is 13.4 KB, how many blocks it will use on disk?
4 blocks.
4 lakhs.
4 blocks. Okay, 13.4 means okay, 4 KB first blocks, 4 KB second block, 4 KB third block. Okay, it means total 12 KB and last block will be 1.4 KB. Okay, but okay, size on disk is 16 KB it used. Understood, guys?
Yes, sir.
Okay, so like this, okay, you take any file. So I have 661 KB file. Okay, so properties. Okay, see here 660 KB point something is the size, but okay, size on the disk is 664. Okay, size on disk will be always okay, multipliers of okay 4 actually. Got it? Because it is 4 KB. Okay, or I have sample.1.txt. Okay, so here if we take properties, okay, so it is not updated. Size on disk it is not updated, but okay, so you can take any important links. Okay, this also, but it's okay, but size on disk will be always 4 KB actually. Okay, or I have hard disk. This is the file. Okay, see, it is okay 50.3 KB, but size on disk is 52 KB. Correct or not? Okay, so whatever I told is correct now or not? This is the proof for you.
Yes, sir. It's correct.
Okay, so in the same way, okay, whatever data you store. Okay, so now, okay, how to see the? Okay, I told that okay, your hard disk will contain the metadata and actual data. How to see the metadata? How to see the actual data? Okay, I have a file. Okay, how to see the metadata for this file? Okay. If you want to see the metadata of this file, right click and click on okay properties. Okay, this is the metadata of the file. Metadata means file name, okay, file path, permissions, timestamps, okay, size. Okay, so here these are the permissions. Okay, okay, timestamps. These are the timestamps when it is created, when it is modified, when it is accessed. Okay, so but okay, can you see the block numbers and all here? Okay, so this will not show you. Okay, the property box will not show you the block numbers and all, except block numbers. All other information it will show. So here, okay, when you right click on a file and click on properties, okay, it means are you accessing metadata or actual data?
Metadata, sir.
Metadata. How to access actual data?
We want to open the file.
Double click. When you double click, okay, you will see the actual data. Understood? Okay. So okay, when I say okay, so now if you see, okay, so I have what file name, the name of the file. Okay, so here metadata is the file name, okay, file size, okay, then okay, file permissions, timestamps, okay, file path, block numbers. All these comes under metadata. So if you want to see the metadata, you need to right click on the file. Okay, if you want to see the actual data, you need to double click on the file. You got the difference now?
Yes, sir.
You got the difference now, right? Okay.
Yes, sir.
So now, okay, so coming back to this one, when it's a data node, it is a slave node in the or worker node in the cluster. Data node is like worker node in the cluster. It is responsible to store actual data in the form of blocks. Okay. What is the responsibility of any data node? It stores the data in the form of blocks. Okay, so your actual data is this one. This is your actual data. Hello, how are you? Okay, but your actual data it is storing, but in the form of blocks. Block 1, block 2, like this. Understood? Understood?
Yes, sir.
Yes, sir.
So
Sir.
it is responsible to serve read and write requests from various file system clients. Okay, so it means okay. So each data node is responsible. Okay, suppose if any writing algorithm command asks data node, okay, data node, okay, write this block in your storage. Okay, data node will write it. Okay, so if any reading algorithm will command ask, okay, so here data node, read block 1 to me, read block 1 and give it to me. Okay, so then data node will read the block 1 and give it to reading algorithm. Understood? Understood, guys? Okay.
Yes, sir.
So it means okay, any writing algorithm asking data node 1 to write, it will write. Any reading algorithm asking data node to read, it will read. Okay. So it's purely depends on okay, what operation it has to do. Okay, purely depends on the algorithm. Okay. And okay, so each data node service okay, will send heartbeat to name node for every 3 seconds. Okay. So each data node okay, will send heartbeat. This is a see. You are connecting writing algorithm is connecting name node whenever you run a command. Okay, once command is completed, then there is no connection between. Okay, I mean, okay, when writing algorithm is, once the execution is completed, the writing algorithm will be closed automatically. Okay, but okay, when you see the cluster here, okay, these people will be okay. So I'll put in a different color. Okay, so these people will be always in touch. Got it, sir? These people will be always in touch. Okay. In touch means okay, every 3 seconds, okay, each data node will send the heartbeat to name node. Okay. So why heartbeat why they introduced heartbeat concept? Okay. So here, okay, I will put the color coding also. Okay, if you see any arrow with the blue color, okay, so it means okay, it is a okay file, okay, write request, read request, file write or read request. Okay. But if you see any arrow okay, in red color, this is a from data node to name node. Yes. Okay. So this blue color is okay, file read request or file write request. Okay. File read or file write. Okay. But okay, this red color is okay, is heartbeat. Okay. But this red color, okay, this heartbeat okay, will go for every 3 seconds, guys. Will go for every 3 seconds. Okay. And okay, updates its presence to and any changes in the storage level. Okay. What it will do, okay, this data node okay will send the heartbeat to name node. In that heartbeat, okay, so data nodes will tell that okay, hey, name node, okay. So I have total storage. Okay, let's say okay. So here, let us take the scenario. So this is the total storage. Total storage. Okay. User storage. Okay. Free storage. Free storage. Okay. So here, okay, total storage is okay. Let's say okay, 100 GB. 100 GB means 1022 for okay, MB. 100 GB. Okay, this is I'm just giving a simple example here. Okay, it is nothing but 1024. Okay, so think that okay, each data node capacity is same. Okay, you can say that okay, this is 100 GB. Okay, so this is 200 GB. Okay, it means okay, so this is again okay, 200 GB. This is a 100 GB. Okay, this is a 100 GB. Let's say. Okay, so okay, so this is the size of the capacity of total storage available in the data node 1. Total storage available data node 2, data node 3, data node 4, data node 5. Okay, so now okay, now how many blocks have been written in this, guys? What is the user storage here? What is user
256
storage?
MB, sir.
128 MB.
Okay.
128
So
MB.
used here is 128 MB. Okay. So used is 128 MB. Okay. Okay. What is free here? Then. Okay. We'll do one thing. Okay. So
102.
used is like 128 MB. Okay. So what is free storage? What is free storage? Okay. This is the one. Okay. So here it is 200 means okay. So 2000. So here use what is used?
128.
So here also it is the same thing. Okay, is it the same thing or here? Okay, two blocks are there. Correct?
256. 256.
Use this 256. Okay. Now this one.
128.
128 MB.
So 307200 128 MB only used. Here 09600 128 MB is used. This is the remaining now. Understood? Okay. So
Yes, sir.
this is okay. So this is the information actually. Okay. So this information each data node will send to name node. Okay. What name node will do this? Name node will do. Name node will maintain one more report here. Okay. So data node information. Okay. It will maintain one more table here. How many data nodes we have here? Okay. So here data node. Okay. Okay. Data node number. Okay. So what is the total of this one? Okay. Total storage, user storage, and free storage. Okay. So here data node 1. Okay. Data node 2. Total five data nodes we have, right? Okay. So data node 5 here. Okay. So this is the table. Okay. Number of blocks also. Okay. So number of blocks. Okay. Okay. What is the total storage here? In the same way, what is the second data node? Okay. Okay. So it's maintaining a table. Okay, number of blocks. So how many number of blocks data node 1 is having now? Only one block, right? Yes or no? Yes. Only one block.
Yes, sir.
Okay. It is a number of blocks 1. Okay. Number of blocks 1. Okay. This is having 2 blocks. One block. Okay. So this is the information. So who will send this information, guys?
Data node, sir.
So each data node will send this information to name node. Now name node will maintain this report here. Okay. Name node will have this report also in place. Understood?
Yes, sir.
So what are the different reports maintained by name node? Okay, so you are seeing here. So name node will have access to centralized metadata, okay, and data node information also. Okay. So inside data node information, okay, you will have clear information like, okay, so what is the total storage from each data node? What is the user storage and what is the free storage? Okay. Now I will delete these lines in. Okay. So now anyway we are okay. So we are maintaining this report, right? Okay. Are you clear till now, guys? Are you clear till now?
Yes, sir.
Yes, sir.
Sir.
Okay. Now, okay, let's say So Venkata is writing one more file. Let's say he is writing sample2.txt. Okay, sample2.txt. Okay, which is of only 50 MB, guys. Okay, so it is of okay. I am fine today. What is the file size here?
50 MB.
Only. So again, okay, the same scenario, right? Okay, so here, okay, so you will execute. Venkata will execute the command, and the writing algorithm will start. So now, okay, now writing algorithm will okay ask name node. Here name node. Okay, I want to write sample2.txt. Okay, can you help me? What name node will tell? Now, name node will check. Okay, in this file whether sample2.txt is available or not. Is it available?
No, sir.
No, it is not available. Okay. So now name node close this of writing algorithm. Now writing algorithm will cut the data into pieces. Okay, what is the default size of the piece?
128 MB, sir.
128 MB. But okay, how much? What is the piece available here?
50 MB.
50 MB.
50 MB. So how many pieces I'll get?
One piece only, sir.
One piece.
Only one piece of size?
50 MB.
50 MB.
50 MB.
Yeah.
128 MB.
Why 128, sir?
But 120 is default, yes. So it 128 only.
Sir, okay, I'm telling that okay, cut your data into 120 MB pieces. Okay. Suppose okay now, okay, you take the previous example itself. Okay. Now I have a file of okay, 9 KB, sir. Okay. How many blocks it will take?
One block.
3 blocks, sir.
3
Three
blocks.
blocks.
4 KB, 4
4K,
KB,
4K, 1K.
1K.
1. Okay. Since okay, so it is the rest of the space is waste. Correct or not? Okay.
Yes, sir.
But okay, since okay, you don't have that extra 3 KB, are you adding anything? A car, okay, your disk is adding anything extra there?
No, sir.
No.
But okay, here the thing is that okay, that extra 3 KB is waste. Correct or not? Okay. But okay, but is it the same case in Hadoop also? You will see here. Okay. So now in Hadoop, okay, is actually Hadoop storing the data or Hadoop is further pushing into hard disk?
Hadoop is pushing to the hard disk.
Hard disk, sir.
Exactly, sir. Okay, see,
Yeah.
now if you see the cluster concept here, okay, if you see the cluster concept here, okay, so here what Hadoop is doing, okay, it is maintaining a set of hard disk like this case. It is maintaining a set of hard disk like this. Okay, this is hard disk 1. Okay, this is hard disk 1. This is hard disk 2. Okay, and this is hard disk 3. Hard disk. Okay. Okay. These are the hard disks. Okay. Now, what is SDFS here, guys? What is SDFS here?
Hadoop distributed file system.
Okay. It is a layer
Connects.
which connects okay all these things. Yes or no? Yes or no? All these disks.
Yes, sir.
into
Yes.
storage. Yes or no?
Yes, sir.
This layer which connects all these multiple hard disks into this is Hadoop SDFS. Yes or no? So now under SDFS, how many we have? How many we have? Okay.
Four.
Okay, so so 4 disks. Think like this. Okay, we have 4 disks actually. Okay, we have 4 disks under SDFS. Okay. Now okay, so what is the block size at this level?
128 MB.
Okay, but what is the block size at this level?
4 KB.
4
Okay.
Okay, so it means okay. So now, okay, so now tell me, is SDFS storing the data? Okay, if you write some data into SDFS, okay, think like this. Okay, you are writing some data into SDFS. Okay, so will you write directly into disk? See, I have some data. Will you write directly into disk or you will write into SDFS?
Write into
Disk,
HDFS.
sir.
You will never write into a disk actually. Okay, you don't know that. Okay, so there is a disk also. Okay, you know only about SDFS. You know about only SDFS. Understood? Okay, so you will write your data into SDFS. Okay, what SDFS will do? Okay, So SDFS, okay, will cut the data into these many pieces and give it to one hard disk. Okay, whichever hard disk is free, it will give there. Are you clear?
Yes, sir.
This is what SDFS is doing. Okay. But actually, if you see, SDFS is the layer which we are seeing. Okay. But okay, what is the actual layer behind SDFS? Hard disks.
Hard disks.
Okay. So now,
Sir,
okay.
I have one doubt if you don't mind. So here
One
can
second,
we take
let me
this?
complete the concept? Okay. So here, okay, I will give you a chance, sir. Okay. So now, okay, I'm putting 256 MB file. Okay. When I put 256 MB, okay, you are giving it SDFS. You are not giving it to hard disk. Correct or not?
Yes, sir.
Huh?
Yes.
Okay. So if you give it to, see, what will happen? What is the difference between giving to hard disk and giving to SDFS? Okay. So if you give it to hard disk, okay, it will be divided to directly 4 KB blocks. So if you give it to hard disk, okay, the entire file will be stored in one hard disk. Okay, and okay, entire file will be divided to 4 KB blocks and stored into one hard disk. Yes or no? Is it clear?
Yes, sir. Clear, sir.
Okay. So, but if you give to SDFS, okay, sir, store in hard disk. Okay, storing in SDFS. What is the difference between storing in hard disk and storing in SDFS? Okay.
Sir, in HDFS, I mean, file is storing in different hard disks.
Oh, okay, so in SDFS, okay, so entire file will be divided into what is the size? What are the blocks?
128 MB.
100 MB blocks and store into different hard disks. Different. This is the difference, guys. Okay. So if storing in SDD, storing in SDFS, this is the difference. Okay. But now, are you storing your data in SDFS or SDD?
HDFS, sir.
SDFS. So
SDFS.
you are giving 256 MB. So then what it will do? So it will be divided into two pieces here. Okay. So 128 MB, 128 MB. So end of the day, what is the size of data going to this disk? What is the size of the data it is going to disk?
4 KB, sir.
Okay.
4 KB.
No. Okay. So here, okay. So what SDFS is giving? Okay. SDFS is giving. Okay. So here it is giving 128 MB here. Yes or no?
Yes, sir.
So SDFS is cutting into pieces and giving it to here. You'll agree with me? Huh?
Yes, sir.
So I will put this one as a blue color. Okay, so that you will understand blue color pieces. Okay. So this is the blue color piece. Okay, so these are the blue color arrows. So this is 128 MB piece. Okay. So these in the same way, second piece maybe may go here. Okay. SDFS has put divide into 128 MB, 128 MB. Okay. Now I have another file, guys. Okay. So I'm writing another file. Okay. Which is of 50. Okay. 130 MB. Understand, sir? Okay. I'm writing another file which is of 130 MB. Okay. How this file will go?
Again, it will cut into two pieces. One is 128.
Okay, so you are storing it here. Okay. Storing it here. Okay. How this will go?
One file will go as a 128 MB and another file is 2 MB.
One file will go like
128 MB, sir.
Okay. 128 MB. Okay. I'll change the color here. I'll put green. Okay, this also green. Okay, other piece,
2 MB, sir.
other piece will go like 2 MB, not okay. Okay, okay, 2 MB. Okay, so it means you are storing 128 MB piece here, you are storing 2 MB piece here. Understood?
Yes, sir.
Okay, so what in case if you write only 50 MB file?
Only 50 MB file will be stored, sir.
I'll put in a red color here. Okay, red color. Okay. Only
50 MB file will be stored, sir. Only one file.
only one piece will come here. Okay, only one piece will come here. That is 50 MB. Okay, so are you clear, sir? Now.
Yes,
Yeah.
sir.
So end of the day, your data is not sitting in HDFS. End of the day, you are sitting. Okay, your data is the hard disk. Okay, so when it is going to hard disk, when this 128 MB is written in the hard disk, how it will be written?
It will be repaired as a 4 KB.
4 KB.
This when 128 is written here, 4 KB pieces. 120 is written here, 4 KB. 2 MB is written 4 KB. 50 MB is written 4 KB. Understood? So now, if I write 50 MB piece of data in hard disk, okay, so will it take 128 MB space? Okay, the extra space will be wasted. Okay, there is no relationship between disk and this 128 MB.
Yes, sir. There is no relationship because here we are storing as a 4 KB block, sir.
No. So here I am putting 50 MB. Okay, so when I put 50 MB file, okay, will it take the will it waste the remaining? Okay.
No, sir, it won't.
No, sir. No,
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 sir.
sir.
It won't waste.
It won't waste.
It will not waste because see, when this 50 MB is coming to this hard disk, it will follow 4 KB block size. Understand?
Yes.
Okay, 50 MB plus 1 KB. Okay, then one block will be with 1 KB. The 3 KB is wasted. That's it. Got it? Okay, so if you are putting data into SDFS, you are not putting data into direct hard disk actually. Okay, that is the reason. So there is no wastage of space case here. There is no wastage of space. Okay, understand? Okay. Now, okay, I will put 1 KB file, guys. 1 KB file. What will happen, guys, if I put 1 KB file? Will Hadoop take or not?
It will take, sir.
It will take, sir.
Obviously, Hadoop will take. How many pieces it will get?
One piece.
One
only.
KB.
One piece. Okay. Of size?
50. 1 KB.
1
KB.
KB.
Okay, 1 KB. Okay. So now, is there any wastage on the disk here?
No.
No.
Yes, sir. 3 KBs will waste.
3
3
KB
KB
is
is
waste,
waste.
right? 3 KB is waste, right? Okay. What is the block size here?
4 KB.
4 KB.
4
And we are
KB.
putting only 1 KB. So 3 KB is waste at this level.
In hard disk level?
Okay, because it is at disk level. Understood, guys? Okay, so this is the clear picture for you. And one more thing is, these are the basics. Okay, this is the these are complete basics of your distributed file system. Okay, if you understand this distributed file system, okay, whatever technology you see from now, okay, till your kids generation, I'm not talking about your generation, sir. Whatever technology you see in future, whatever new technology you see in the future, okay, so till your kids generation, okay, the same concept will run, sir. Understood?
Yeah.
Yes. So whatever I'm teaching you today, you will remember me. Okay, if you remember this concept, you'll remember me for next okay, till your end of life. That is the kind of concepts we are learning today. Understand? Okay. So if you write 50 MB again, okay. So now, okay. So 50 MB will be written. Okay. So piece one. Okay. So and okay, inside this 51. Okay. So 50 MB. This is the I'm fine today. This is the end of okay 50 MB. Okay. Now blocks we will have here? How many blocks we will have? I'll get only one block, right?
Only one block, yes.
So name node will say, okay, write your data in, okay, with name VLK003, okay, and put it into data node 2, data node 4, comma data node 5. Okay. So now when 50 MB is written here, it will go like 50 MB only. Okay. So here block 3. So BLK 03 R size 50 MB. Okay. So now this is the content of this one. Okay. So this is the content of this. Okay. So 50 MB here. So here 50 MB, here 50 MB. Okay. So now tell me, okay. So once, okay, the blocks are written successfully, obviously metadata will be updated here. Yes or no? So now 2, serial number 2, sample2.txt. Okay. So Venkata, okay, the block size 128 MB, file size 50 MB.
50 MB.
50 MB. Block numbers, okay. BLK 003, okay. So data node 2, data node 4, data node 5. Are you clear, sir? Are you clear? Are any questions? So it is updated here. Okay. Once it is updated here, immediately what data nodes will do? Data nodes will be sending heartbeat to name node every 3 seconds, right? In the next 3 seconds, this data node will inform name node saying, hey name node, I got one extra block in my storage. Okay. So extra 50 MB is used. Update your records. Immediately what name node will do? So for data node 2, okay, it will update the storage like, okay, so 178 MB. Yes or no? Why 178 here? 178 guys. Total. Block 1 is 128. Okay. Block 3 is 50. Total 178. Okay. And data node 4 also will say I have 178. Okay. Data node 5 also will say I have 178. Okay. And number of blocks. Data node will say I have 2 blocks. Data node 5 will data node 4 will say I have 2 blocks. 5 will say I have 2 blocks. Okay. It means, okay, whenever there is a change, okay, in these data nodes, whenever there is a change in the data nodes, okay, immediately within 3 seconds, okay, it will be reflected, okay, in the name node report. Understood, guys?
Yes, sir.
Whenever there is any change, it will be reflected in the name node report within 3 seconds. There won't be much delay also. Okay. So that's what I said. Okay. So here, send heartbeat to name node for every 3 seconds and update its presence and any changes in the storage layer level. Storage level. Any changes means if new block comes, okay, it will update. Okay. Okay. Now, if somebody deleted the sample2.txt, if you delete, okay, then okay, the blocks will go off, right? If the block is deleted also, okay, it will tell, hey, earlier I had 2 blocks, now 1 block is deleted. I have only 1 block. Please update my records. So my user story is 128 MB, only 1 block, like that. So when a new block is stored in the data nodes, or when the existing blocks are deleted from the data nodes, immediately within 3 seconds, that information will be reached to name node. Are you clear?
Yes, sir.
Yes, sir.
Clear, right? Okay. So the next line is, okay, performs block creation, block replication, and block deletion operations. And
Sir, one doubt, sir.
Yes, sir. Okay,
Sir,
somebody asked me doubt. I told, okay, I will give a chance. Right? Please ask that question also. I forgot. Sorry.
sir, that duplicate data is also storing in the hard disk in the form of 4 KB.
Of course, yes. Every data is storing in the form of 4 KB only, right?
Sir, those duplicate data is also the replication data that.
Yes, sir. Why is this question? What made you to think like this?
No, sir, I was just asking about this. Sir, that you told na that one time 128 MB is passing to that hard disk. So I was thinking that a replication data, you have not shown that replication data will also be storing in that hard disk.
Sir, okay. In this picture, I didn't show, sir, because I don't have space, right?
Okay.
One copy only have shown. One copy only have shown. Got it? Okay. But okay, so but here I'm showing the replicas also. Okay, guys, please be on mute.
Sir,
మీకు యాప్ పంపిస్తాను చూడండి.
Sir.
Sir, so you said that a name node maintains two
Reports.
two metadata. One is meant for
Yes.
filtering,
Yes.
and
Yes.
it will maintain data node information separately, right?
Exactly, sir. Exactly.
Okay.
These are two separate tables maintained by name node.
Okay.
Okay.
Okay, sir.
Now,
And
status. Okay.
Venkit, this replication
Excuse me, sir.
thing will be maintained, will be will be taken care by writing algorithm only.
Of course, yes.
Okay. So it will only make sure that it will be replicated 3 times in.
Exactly.
different-
While writing,
CFS, that can be done.
now, once data is written successfully, sir. Okay, let us take this scenario. Okay. Now, okay. So now come back to this point. Okay. First block creation. What even a block creation, sir? While writing the data. Okay. So, okay. While writing the data, what writing algorithm will do? Writing algorithm will say data node 1, hey, or data node 2, hey, can you write my data? It means it is creating a new block. Yes or no?
Yes, sir.
It is writing the new block in its storage. Okay, this is called as block creation. You see, writing algorithm is asking data node 2, hey, data node 2, I have 50 MBPs. Okay, write this 50 MBPs with the BLK003. Okay, file name. Okay, now it will write the data node 2 will write the new piece of data into its storage. It means okay, it is like it is creating a new block in this storage. Yes or no?
Yes.
So that is called block creation. Okay. Then the next one is block replication. What do you mean of block replication, sir? Suppose due to some issue, if data node 1 is down. Due to some issue, data node, okay. So this data node 1 is down, sir. Okay. If data node 1 is down, okay. So block 1 is available here. So one copy of block 1 is gone. Yes or no?
Yes, sir.
Yes.
So one copy of block 1 is gone. Okay. So how this okay, it means okay, I have only 2 copies. Okay. But okay, I need 3 copies. How that extra copy will be created now? Okay. So when data node 1 is gone, so what will happen? Data node will
Bits into the.
no heartbeats. Yes or no? Yes or no?
Yes,
So if
sir.
data node 1 is up and running, then okay, heartbeat will go. If there is no heartbeat,
No
Data
heartbeat.
node is inactive.
it means okay, this will go to inactive. So immediately status will become inactive. Okay. So now, but here there is a block here. Okay. So now okay, name node understood that okay. Okay. Because of data node 1 failure, okay. So one block is having under replication. What do you mean of under replication? How many copies I'm supposed to have? 3 copies.
3 copies.
Okay. But because of this data node failure, okay, I lost 1 copy, but I have only 2 copies now. Yes or no?
Yes,
I
sir.
lost 1 copy.
Yes.
I have only 2 copies now. Okay. So now what to do?
We'll create 1 more copy.
Okay. Who has to create this 1 more copy now?
But writing algorithm is already finished. Yes.
Writing algorithm already finished. Okay. So
Name node.
then okay, it is the responsibility of name node to make sure you have all 3 copies available for each block. Understood? Okay. So now what name node will tell? Okay, name node knows that okay, it has block 1 in these 2 nodes, correct? Huh? So
Yes,
now name node will tell, hey, data node 3, okay, you send a copy of block 1 to, okay, so block 1 to, okay, to this node. Okay, in this scenario, okay, your data is coming from, see, in this scenario, when you are creating a new block, data is coming from writing algorithm to, okay, data node and storage, correct?
Yes,
So
sir.
writing algorithm to data node and from there create storage. So this is okay, block creation. Yes or no?
Yes, sir.
Yes.
Block creation. Okay. So okay, but now here because of one data node failure, so one block is having one less copy. Okay. Now okay. Do we have writing algorithm concept here now? No writing algorithm. It is already finished.
Yes.
Correct or
Yes.
not? Okay, so now you have data node to data node. Data node to data node. Okay, one data, your block is copying from one data node to other data node. Okay, this is called as block replication. You should know the difference between block creation and block replication.
Yes, sir.
You got the difference between block creation and replication? When replication will happen?
When some data node is damaged.
When
I don't
you
know
miss some of the blocks. Okay, the replication will
So
happen.
block replication is taken care by name node.
By
but
name node
block creation-
automatically.
yeah, but
Automatically.
automatically. But
Yes.
block creation is taken care by writing
Algorithm.
algorithm.
Okay, again, right, end of the writing, for writing algorithm also, who will give the instructions?
Name node only is giving.
Exactly, sir.
Sir, is it always 3 blocks or more than 3 blocks?
You can have, okay, see, it's up to you, okay? So, replication, is it always 3?
No.
So, this is okay, equal to 3 is default.
Okay.
Default, okay? So, it means, okay, so if you tell I want 3 copies, okay? Hadoop will maintain 3 copies. If you tell, okay, I want 10 copies of my file, it will maintain 10 copies for you.
Okay, sir.
Okay? So you can customize. Yes or no? But if you tell, okay, Hadoop, okay, hey, Hadoop, okay, I want only 2 copies, it will maintain only 2 copies for you. Okay? But if you don't tell how many copies, what it will do?
Default 3.
By default, it maintains 3 copies.
Yes or no?
Sir,
Understood, madam, concept or no?
Yes, sir. Yes, sir.
Yeah.
sir, the block size is default 128, sir.
So here also block size also. So block size. Okay, in Hadoop, okay, one good thing is that, okay, you have default numbers and okay, you can customize to any number also. Okay, so the default number is 128 MB. Okay, yes or no?
Yes, sir.
I don't like these 3. Okay, 128 MB piece. Okay, I want, okay, so this is default. Okay, so if you don't tell what is the size of piece size, then they'll go with, Hadoop will go with 128 MB piece. But if we say, okay, I want block size of 200 MB.
64.
200 MB. I put a block size of 200 MB. You can put, who will say no? Okay. So I say block size of 100 MB also. You put, who will say no? Very simple, sir. Okay. Okay. So Saturday, I'm telling some non-veg concept. Okay. Suppose if we go to chicken shop, sir, or mutton shop. Okay. If you don't say anything, what is the piece size? What they will do? They'll give a normal. They'll cut into normal pieces. But if you say, hey, sir, I want biryani pieces, what they will do? They'll give big pieces. Okay, no, sir, I want keema or kaima, whatever it is. Okay, so they'll give very small pieces. Okay, like that. Okay, you have an option to customize in everything in Hadoop.
So likewise, can we customize the disk size also? Like for default 4 KB, right? So can we customize into?
Of course, yes. Of course, yes. That's what I told, right? That's what I told, right?
And what about heartbeat, sir? It will give.
Of course, heartbeat also, sir. I told anything you can customize. Okay, what is heartbeat default?
Okay.
How frequently heartbeat will go here?
3 seconds.
Okay. If you feel 3 seconds is okay, too much. Okay, you make it like 10 seconds.
Okay.
Then okay, every 10 seconds, okay, data node will send heartbeat to name node, and data node will pass this information every 10 seconds once.
But too much customization may lead to
slowness,
performance degradation. Yes.
Yes, sir. Yes, sir.
So you can customize in everything in Hadoop.
Yes, sir. Yes, sir.
I have 2 questions, sir. So
yes, sir. Please go ahead.
In the event of name node, data node goes down, there is usually a lot of data, right? Like plenty of data.
Yes,
to
sir.
replicate to a different data nodes.
Yes,
So
sir.
is that all going to be automatic, and it's not, it's and also it's going to be like
Even
node-
it is terabytes of data also, it is automatic process, sir.
okay.
If I have 10,000 blocks in one data node also, if that data node is down, okay, all 10,000 blocks have to be replicated.
And it
That
and
is
it's
the
going
process.
to be okay. And it's going to be done like ASAP as soon as the name node
Exactly,
knows
sir.
about it.
Exactly.
Is there any specific job that's going to initiate in the backend for that?
Yes, sir. Okay. Specific replication algorithm okay, will be invoked by name node. You may not see that actually. Okay.
Okay.
But
and the
okay.
second question. Okay.
Hmm.
And the second question is, if you move on to the disk tab over there, left side, sorry, the other page.
Okay.
Yeah. Here, can I assume that actual data, that disk, right? Can I assume that disk is part of one specific node, one specific data node?
Of course, yes, yes, yes.
Okay, so here we are having this 4 disk, which means 4 nodes, and the volume.
Sir, okay, it can be like this also, right? Okay, so when I say, okay, see, normally, okay, SDFS, under SDFS, okay, you have, okay, so what is SDFS guys normally? Okay, so now you have a server, sir, okay, server 1, okay, server 2, okay, server 2, okay, server 2, server 3, server 4, server 5, okay, server 5. Okay, sir, take it like this, okay? These are 4 servers, okay? It's a server, okay? How many hard disks you can have in one server, sir? Normally, if you see a laptop, okay, how many hard disks you will have in laptop?
One.
One hard disk, right? But inside server, have you ever
can
seen
have
server?
connected to the
Have you ever seen server?
Yep, in the data center.
Okay, so server rack. So what is the server, sir? This is the server. Okay, so I'll have to okay, rack server. You see this one, sir? What is this one, sir? What is this one? This is a server, sir.
Server
Rack
with
server.
different disks, yes.
This is a server, sir. This is a server. Okay. And what is this slot, sir? Can you see this one?
Yes. So these are the disks.
Okay. See, normally, if you see your hard disk, okay, you will have option for single hard disk. Okay. But if you buy servers, okay, you will have multiple hard disks, sir. Disk 1, okay, disk 2, like this. Okay, you can have up to disk 26. So you have option to put okay these many disks actually in each server. Okay. So now again, okay, is any rule that okay every disk okay should be of same size?
No, sir.
No.
Okay. So now think that okay. So in each machine okay, I'm using only 3 disks. Okay. So okay, 3 disks. Okay. So now what is SDFS? What is SDFS? Okay. So in this machine I'm running name node machine. In this machine I'm running data node service, data node service, data node service, data node service. Okay. So now, okay. So what is SDFS? The sum of all the hard disk from the data node is the SDFS. This is SDFS, sir. Understood? So it means okay. So when I say one disk, okay, in a server, okay, you can have multiple hard disk also. It is not like a single hard disk. So now, if each hard disk is okay, of 1 TB. Okay, if each hard disk of 1 TB. Okay, in one single server, how much TB we have?
26 TBs.
26 TB. Okay. Here was 26, 26, 26. What is the total storage now? 104 TB. Understood?
Yes, sir.
Okay. So it works in this way, guys.
Sir, is there a minimum or maximum capacity of disk?
No, 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 no. You can use any size.
Okay, there is no maximum size also.
So whatever is available in the market, you can use that, sir. Very simple.
Okay.
If you
Okay.
want to do anything with the HDFS to access the data, we usually go through the data node. Is what it is,
Okay.
right? I mean,
No. Okay. Think that as of now, think that okay, I will come to that point also, sir. Okay. As of now, you think that okay, so it will be through data node. Okay. So RKS, you can access from anywhere, right? So this is your Hadoop cluster now. Yes or no?
Yes,
So
sir.
yes.
this is okay. What is Hadoop cluster? This all together Hadoop cluster. What is SDFS? Data node disk equal to SDFS. Okay. Now I'll put it here. Okay. What is SDFS? This is SDFS. The yellow color one is SDFS. You should understand what the difference between SDFS and cluster.
So name node is also part of the HDFS, sir?
Name node is not part of SDFS, right? Okay. Name node is part of cluster. Now you tell me. Tell me, sir. Okay. You got the difference between okay, what is cluster and okay, SDFS?
Understood, sir.
Inside cluster, okay, you will have multiple servers. Yes or no? But okay, so all servers together you call as a cluster. Okay, but what is SDFS? Wherever data node service is running, okay, so that machine storage only. Okay, that machine storage is treated like SDFS. Understood? So, okay, now what is cluster capacity?
Cluster capacity, it's like unlimited only.
We have like
in this picture, cluster capacity is
104. Yeah,
104.
No. Cluster capacity is including name node.
Yeah, correct. Yeah.
Okay, but okay, SDFS capacity?
104.
You got the difference now.
Yes, sir.
So cluster capacity is including all the nodes. Okay, SDFS capacity is only data nodes hard disk. Understood?
Yes, sir.
Okay. So here, okay. So okay, coming back to this part. So all questions are cleared, guys. Or anybody else has any question?
Sir, I have a question.
Sir, please.
Regarding block replication. Like suppose we have a default replication which is 3.
Okay.
Whenever a data node is down, it is copying data from one data node to other data node to make it as 3.
Yes, sir.
So what happens if a data node which is down is up again?
Okay, so it means okay. Suppose okay, if data node is down, what is happening? If data node is down, okay, this copy is not available. Correct?
Yes.
Okay, then I have 2 copies, so it is creating 1 extra copy here. Yes or no? Okay. If data node is back, okay, now I have this copy. Okay. Now how many copies? Okay, it has now
4 copies.
4 copies.
So it means excess copies, right?
Yes, sir.
Okay. So excess copy will be deleted by name node.
Okay, automatically.
It's an automatic process again. Okay. So creating the block, okay, block creation is okay. Block replication is taken care by name node. Okay. If it is excess blocks, okay, deleting excess blocks also responsibility of name node. Okay. But okay, here, okay, now deleting this block. Okay, will name node come and delete here? Okay, name node will tell data node 5 delete this block.
Yeah, and data node will
name node.
Name node will tell data node 5 to delete this block. Now data node 5 delete this block.
Sir, usually relocation will happen once data node be added, right, sir? Relocation.
Yes, sir. Yes, sir.
To normalize the load on the DNs. Like
yes.
If some DN is more occupied, then that will be normalized using a relocation. The data will be transferred to new one.
Exactly, sir. That is balancing actually.
That's correct.
Yeah. Okay. Understood, sir. See here, okay, in this scenario also, suppose, okay, if data node 1 is down, okay, is name node creating the block here? Or, okay, name node is telling this data node 3, hey, give a copy to data node 5. See, name node is kind of a manager, guys. Name node is kind of a manager. It will not work, but it will give the directions. Understand?
Yes, sir.
Name node will not work, but name node will give the directions. Clear? Or any questions?
Clear, sir.
Okay. So anything, okay, so block creation will be done by name node. Okay, block deletion will be done by name node. Okay, when I say done by name node, okay, doesn't mean, okay, name node will do. With the name node instructions, somebody else will do. Data nodes will do. But end of the day, the work, actual work is started from name node. Right? That is the reason, okay, we say like, okay, it will be done by name node. Got it?
Sir, if any block is deleted, even that information will be stored. Like.
Okay, everything will be stored in name node.
Okay.
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 Yeah. Okay. So block creation, block replication, block deletion operations. Okay, upon instructions from name node. See here. Want to create a block creation. Okay. Without name node instructions, can data node automatically create a block? No.
No, sir.
Okay. So block replication without name node instructions. Okay. Will a block be automatically replicated?
No, sir.
So, okay, without the name node instructions, will a block will be automatically deleted by data node? No. Okay. So data node is kind of a worker node or a slave. Okay. Whatever master will tell, slave will listen. Okay. If master say, hey, create this block, it will create. Master say, replicate this block, it will replicate. Okay, delete this block, delete this block. Clear?
Yes, sir.
Are any questions? Okay. So I hope it is clear. So now how file is stored in HDFS? Okay, so here, okay, this is your large file. So normally any file, okay, you write into HDFS, it will be divided into blocks. Okay, and each block, okay, will be written in the respective data nodes. Okay, so this is the name node. The big box is name node. Okay, so the small boxes are data nodes. Are you clear?
Yes, sir.
Okay, yeah, this is how the file writing operation will work here. Okay, so I hope it is clear, guys. I hope it is clear today.
Venkat, generally, just a query, like generally, what will be the configuration for name node we see in production, or like
okay,
generally
sir,
in
okay.
a cluster? Yeah.
We will talk about that, sir. Okay, we need some more time actually. Okay,
Sure,
but okay, some more time is okay. 2-3 days, sir. Give me 2 days. Okay, but okay. So, but if you need answer, okay, okay. Normally you will have okay high-end system, okay, like 256 GB RAM or 512 GB RAM. But okay, what is correct number of RAM you need to use for name node? So there is a calculation for that. Okay, which I'll be teaching in the cluster planning.
Okay, got it.
Yeah.
Thank you.
Okay, yeah. Any questions till now? Okay. If no questions, okay, we will see the next point. HDFS key points. What are the key points here? Okay. When I say HDFS key points, okay, the default block size. Okay. So here, okay, I'm saying Hadoop 1x, 2x, 3x. What is 1x, 2x, 3x, guys? Version actually. Okay. So here, okay, Android 6, Android 7, okay, Android 8, okay, Android 11. What are these actually? Versions actually. In the same way, Hadoop also having versions actually. In Hadoop 1x, the default block size is 64 MB. Okay. In Hadoop 2x, okay, default block size is 128 MB. In Hadoop 3x, default block size is 256 MB. Okay. So every file, okay, and okay, in all the Hadoop versions, okay, you can customize your block size if you want. Understand?
So till now we have discussed about Hadoop 2x, no sir?
Also think that Hadoop 1x only, sir, or Hadoop, any Hadoop, okay, and till now I discussed about general Hadoop. 1x, 2x, 3x, all.
Okay.
Okay. So here every file, okay, in Hadoop, okay, or HDFS, okay, every file will be divided into blocks. Okay, and each block is replicated 3 times. What you understood, guys? Each block will be replicated 3 times by default. Okay, but can I increase or decrease the replication factor? Yes, right. I can increase.
Yes.
I can increase the replication. Okay, if I want, okay, I can customize. Okay, but okay, block is never replicated on the same data node. Okay, replication is fine. Okay, so suppose, okay, let us take the scenario. If data node 1 is down, okay, so do you think, okay, it will keep one more copy of the block in this machine? What is the use of, okay, keeping block 1 2 times in the same machine?
No use of. If it is down, complete data will lost.
So okay, you will think that, okay, I have 2 copies, but okay, if data node 2 is down, okay, your 2 copies will be lost. Okay, that's the reason. Okay, so no 2 data node. Okay, so no data node will have same copy of the blocks twice. Got it? No 2 data nodes will. So no data nodes will have 2 copies of same block. Understand? So each data node. Okay, if I say block 1 will data node each data. Okay, data node will have only 1 copy of block 1. Okay, never 2 copies of block 1 in the same data node. Got it?
Yes, sir.
So what if we have only 2 nodes? Then
and the replication equal to 3.
Yes.
Okay.
No, if you have 3 replication, so then obviously there is no chance to store in some other.
In that scenario, okay, it will keep, okay, 1 copy in one node, 1 copy in a second copy in second node, but okay, it will be waiting for third node. Okay, so but if you see the name node report, it will show like, okay, so under replication for this file. Okay, it is supposed to have 3 copies, but okay, because of less number of data nodes, okay, we are maintaining only 2 copies, so it is under replication. So whenever you add third data node, automatically name node will create third copy.
So it won't store in second node.
No. Okay, that's what, okay, I'm saying. That's what I'm saying. Okay.
Okay.
Clear. Okay. Okay. So data can files are write once and files are write once and read many. What do you mean of write once and read many?
Yeah, after writing, we can read many times, sir.
Many times. Okay, you write once. Okay, you read. Okay, how many times you want? Okay, you can read those many times. If you want to read 100 times, you can read 100 times. Okay, there is no limit for that. Okay, and data can be appended to a file, but the file existing content cannot be changed. Okay, so this is a bit tricky point, guys. Okay, so let us take one file, guys. Okay, let's say I have 1 TB of data, guys. 1 TB of data. Okay. So when I put 1 TB of data into Hadoop cluster, how many blocks it will give you? 8192. 128 MB blocks it will get. 1 TB will be divided into how many blocks? So here, okay, it is like this actually. Okay, so here block 1. This is block 1. Okay, I'll open some other thing. Okay, so now, okay, so here, okay, let's say this is block 1. This is block 1. Okay. This is block 2. Okay. This is block 3. Okay. This is block. Okay. So block edit. Okay. So the block 1. Okay. So okay. So here this is block 8192. Okay. So how that data will go here? Okay. Block 1, block 2. Like this it will go, correct? Okay. So block 1, block 2, block 3, block 4. Okay. So here, okay, block 1. So see here, guys. Okay, this is block 1, block 2. This is block 3. This is block 8192. Okay. So these are these many blocks. Okay, I have 1 TB file I put. Okay. I have 8192 blocks. Okay. Now, okay. If I add, okay, so if I add any file, okay, any data in between, if I add any data in between, what will happen? It has to shift, okay. Otherwise, okay, I'll put my data. Okay, this is 128 MB, sir. Yeah, this is 128 MB. Okay, so now this is the data. This is the data it is filled with. These are the blocks. Okay. Now, okay, if you want any data, if you want to add anything in between, okay, if you want to add anything in between, okay, this is the data you have. Okay, if you add anything, okay, this is 128 MB. Suppose, okay, if you add any data here, what will happen, guys? So data, okay, so here, okay, so data, okay, row 1. Okay, row 7, okay, row 8. Row. Like this, sir. Let's say this is my data, sir. This is my 1 TB data. Okay. Now, if you want to add something, okay, here, okay, the size of this one is okay, 128 MB, okay, total 8192 blocks, 8192 blocks. Okay. Suppose, okay, if you want to add, okay, row 4.1, okay, what will happen, guys? If you add, okay, after row 4, okay, you want to add row 4.1, what will happen, sir? Suppose, okay, if I add, okay, row 4.1, okay, what will be the size of this file? This will become 150 MB, right? Yes or no? Before adding row 4.1, it is 128 MB. Now I added, okay, row 4.1 here, 150 MB. So that because of this one extra piece, extra data addition, okay, so the block size has increased 150 MB. Then, okay, it has to adjust here, right? Yes or no?
Yes, sir.
Okay, so when that extra, okay, so it means, okay, I need to send row 7 here. When I send row 7 here, again, I need to send row 14 here, row 15 to, okay, row 21 to here. Okay, it means, okay, if you add anything in between, that will impact all the blocks. That is the reason what Hadoop is saying. Okay, we don't have any chance to add anything in between. Okay? If you want to add anything, okay, you add at the end of the file, not in between of the file. Got it? You want to insert extra record, you add at the end, not in between. Got it? Okay, that's what, okay, we are saying here. Okay, so data can be appended to a file, but the file existing content cannot be changed. Okay, existing content in between, okay, you cannot do anything. Okay, If you want to add, you can add at the end of the file, but not in middle of the file, anything. Clear? So this is kind of a drawback, right?
But Venkat, how does it matter? Because at the end of the day, it is storing in hard disk in 4 KB pieces only.
Yes. Okay. But okay. That's what, sir. Okay. So this is in data node 1. This is in data node 2. This is data node 3, data node 10, data node 8000. So here, okay, I have to change each and every block, right? Don't you think it is a tedious process?
Yes.
Okay, that's the reason they are not allowing, but otherwise, okay, yes. Okay. Okay, so to maintain the standard of 128 MB, so they're not allowing to make the changes in middle. Understand? Okay.
Okay.
Yes. Okay. We'll stop it here. Okay. So we'll continue because okay, even if I start this concept, okay. So what is the time now? Okay, time is okay 8:51. Okay, I cannot complete this concept in 9 minutes. Okay, so we'll start firstly on Monday morning. Okay.
Sir, which version of Hadoop is in use now and which is out?
Now okay, 3x, sir. Everywhere it is 3x.
Okay, sir. So 2x and 1x is not in use much.
2x, okay. In some companies, still 2x is there.
Okay, sir.
Yeah. Okay, guys. Okay. Enjoy the weekend and see you all on what is it? Monday. And guys, okay, if there are some people I did not allow today. Okay, so if any of your friends are not yet paid, okay, so ask them to pay and continue from Monday. Okay.
Sir, thank you.
Thank you, guys. Thank you all.
Thank you, sir.
Thank you, sir.